Hi everyone, this is Mrs. Musoff here. Today we're going to be talking about analyzing and graphing piecewise functions. Now remember, a piecewise function, it's a function that looks like it's broken up into different pieces with different parts of the graph in different sections of the coordinate plane. So for example, we could have one equation that applies to these x values, and then we'll have a different equation that applies to these other x values. Even though these pieces aren't continuous, like they're broken apart, we can still analyze them and graph them, so it's important that we know how to do that. Okay? When we graph a piecewise function, we're only graphing each piece in that specific region, and they'll tell you that region in the conditions. So for example, example 1 gives us a function f of x equals, and we've got two pieces. We've got 2x minus 1. Oops, let's use a different color. And then we have negative 1/2 x plus 3. Alright, so two different pieces, and it tells us, okay, 2x minus 1 applies only if x is less than negative 2. So we're only going to graph that piece on the x values that are smaller than negative 2. So one thing I like to do is kind of take my pencil, and you'll notice that these two conditions typically match up with the same number. So I'll take my pencil and I'll draw kind of a dashed line at that number, so I know that's where my graph should split. Right, that's where I should have two different graphs, one on the left side, one on the right side. So here, because this first equation is for x is less than negative 2, and the second equation is for x is greater than or equal to negative 2, I know that my condition number is going to be negative 2. So I'm going to draw a little dashed line on my graph. It just helps me stay organized and know exactly what I should be expecting. Now I know I should be expecting one graph on the left side of this line and a different graph on the right side. Okay. Now, to graph these, you might remember like y equals mx plus b, and you can always use that to help out. The only problem is, in y equals mx plus b, we usually start with the y-intercept. Well, only one side of this graph has a y-intercept, so it can be kind of hard to use that when we're doing piecewise functions. So instead, we like to use tables. Alright, so I'm going to start with my first piece here, and remember f of x is the same thing as just saying y equals, so if you're ever confused by the f of x, just change it to y. So this first piece is y equals 2x minus 1. And then my second table is for my second piece, so y equals negative 1/2 x plus 3. Okay, now when we're making a table, usually we make a list of like a bunch of points. But the nice thing about piecewise functions, at least the ones we're doing, is they'll all be linear. And in order to graph a linear equation, you really just need 2 points. So we're only going to pick 2 points for our table. There is an exception, though. For both of these tables, 1 point has to be the condition point. So, whoops. 1 point has... I don't know why this is writing so funny. There we go. 1 point has to be that number. Okay, the number that they kind of use as like your boundary. So you could kind of think of it as the boundary number. One point has to be the boundary number. So for both of these graphs, the first x value that I'm going to choose is negative 2. For both of them. Now you might be thinking, but this one, it can't equal to negative 2. It has to be less than negative 2. And you're right, but we still need to use negative 2 as our jumping off point. Alright, so both of these tables will have negative 2. For the second x value, let's just go back to my first table now. I can pick any x value I want as long as it satisfies this inequality. So this inequality says that x is smaller than negative 2. That means I need to pick an x value that's smaller than negative 2. Oops, sorry about that. There we go. Alright, so in other words, like to the left on the x-axis, if you want to look at your x-axis, just to help you out. Okay, so I'm just going to make it easy for myself. I'm just going to pick one that's, not too big, so maybe like negative 4. And to figure out my y value, I'm going to plug these x values in. So it'll be y equals 2 times negative 2 minus 1. 2 times negative 2 is negative 4, minus 1 is negative 5. Alright, and I'll do the same thing for my second one. 2 times negative 4 minus 1. So that's negative 8 minus 1 is negative 9. All right, so I have my 2 points here. I have negative 2, negative 5, and I have negative 4, negative 9. Now, before I plot them, we do have to come back to this idea that this inequality said not equal to negative 2. It said it has to be smaller than negative 2. What that means is when we graph these, sorry about that. When we graph these, this boundary point, which is what I call the point that we use with your condition, so I'm going to write boundary point. Sometimes it's an open circle because it can't equal it, and sometimes it's a closed circle if it's supposed to equal it. So since this one is not equal to, that line's not there, this is going to be an open circle. All right, because it doesn't satisfy the inequality, it's just our boundary point. So when I graph it, negative 2, negative 5, I'm actually going to make it like an open circle just like that. Okay, only boundary points are open or closed. Right, those are the only points you have to decide if it's open or closed. All other points would be closed. So the second point that I came up with is just going to be a normal point. Closed point, negative 4, negative 9. Alright, now since this point is to the left of that boundary line, I know that this graph is only going to be on this left side. So when I draw it, maybe a little better than that. There we go. I'm only starting at my boundary, drawing it towards that left point, and then putting an arrow on the end. It's not going both ways, just one way. Alright, and we'll do the same thing for our second equation. So I already picked my boundary point. Now I just need one other number. Sorry about that. Alright, one other number, and at this time, take a look at this. It says x is greater than or equal to negative 2. So x is bigger than or equal to negative 2. So when I choose my x value, I need to be conscious of that, and I need to make sure I pick my second x value that's bigger than it. One number that's always a nice one to pick is 0. So if 0 ever applies, I would try that one because it's an easy one to plug in. And here 0 is bigger than negative 2. So I can use that, and then I'll plug these in. Y equals negative 1/2 times negative 2 plus 3. I know the fractions can be tough, and these piecewise ones are pretty challenging, so if you need to use your calculator to help you out, feel free. Negative 1/2 times negative 2 is going to be positive 1 plus 3 is 4. And then I'll do the same thing for 0. Negative 1/2 times 0 plus 3. Okay, remember, anything times 0 is 0, so this will just be 3. So once again, I have these points. I have negative 2, 4, and then 0, 3. Again, remember that first one is my boundary point, so I do need to ask myself if it's going to be open or closed. Typically, because it's a function, one will be open, one will be closed. You should never have both closed. So if you weren't sure, you could look and say, oh, the last one was open. This one's probably closed. But what really tells you is this equal to part. The equal to is what says, oh, well, then this is going to be a closed point. And the second one's not a boundary, so it's automatically closed. So negative 2, positive 4, close it up, and then 0, 3. And since this is the part of the graph that's happening to the right, I'm only going to draw my arrow going to the right side. And that's it. We've graphed our piecewise function. All right, now usually you might not have these tables drawn in for you, so you might have to do that part yourself. So if you feel like you need another example just to show you what that would look like, then watch that next video that has a second example of graphing. Okay, for now, we're just going to do one more example because that was graphing, but we also want to be able to evaluate. So I'm going to go ahead and skip down here to example 4. So take a look at the example 4 that's on your notes. Alright, so in this example, it says using the function below, evaluate the following. Evaluate just means like, what does it equal? What does it equal? And it's basically just using function notation, which we talked a little bit about the other day, and then we talked more about last week. Alright, the tricky part here is because it's a piecewise function, you have to be a little more careful because there are 3, count them, 1, 2, 3 different pieces that you could potentially plug these numbers in, and you need to make sure you're only plugging it in for one. So for a piecewise, whoa, sorry about that. For a piecewise, only ever plug x into one piece. Because remember, for it to be a function, each x can only have one y. So you can't plug it into all three pieces because then you'll get three different y's. That wouldn't make sense. All right. So the way we figure out which one to plug it into is based on our conditions over here on the right. All right. If your x value satisfies one of these conditions, then you know you'll plug it into that equation. For example, part A, it says f of -8. Remember, that means what's y when x is -8. So, to figure out which equation I'm going to use, 1, 2, or 3, I'm going to test -8 in each one of these conditions. And whichever one it satisfies, that's the one I'm going to plug it in for. Alright, so I'll start with this first one. Is -8 less than or equal to -5? Well, since -8 is more negative, that means it is smaller than -5, so this one checks out. So I know I'm going to use equation 1 in order to plug this in. So I don't even have to test the other ones since this first one worked. I'm just going to plug it into my first equation. So 4 times the absolute value of -8 minus 2 plus 1. Alright, and then we can evaluate. Now be careful, absolute values, remember, it's distance, so it makes the number inside positive. So this will be 4 times the absolute value of -10 plus 1. Absolute value of -10 should become positive 10. So 4 times positive 10 is 40, plus 1 is 41. So there's my one single answer. Okay. If we tried another example, like let's say, I don't know, e over here. It says f of 2. So again, what's y equal when x is 2? Once again, I'm going to test it out in these equations. So in this top one, I'm going to say, is 2 less than or equal to -5? And I'll say, no, 2 is definitely not smaller than -5. It's bigger. So I'll say, nope, not the first one. All right, and then I'll test it in the second one. I'll say, is -5 less than 2 less than or equal to 2? In other words, is 2 in between -5 and 2? And it could equal 2, because see that symbol there? Equal to. Well, 2 does equal 2, so that means it is going to fit in this middle equation. So for this one, I'm going to use equation 2. And I'm going to plug it in. So the equation is -x plus 10, so it'll be -2 plus 10. And -2 plus 10, that's going to be 8. So there's my answer. Alright, so for these types of problems, you just have to be a little careful and make sure that you're really double checking and using the correct equation. Alright, just to give you one more, let's try letter G down here. Alright, this one right here. So f of 18. So remember, that's what does y equal when x is 18? Well, 18, I'll test that one also, is 18 less than or equal to -5? Nope, that's way bigger. Is 18 in between -5 and 2, where it could equal 2? No, definitely not, because 18 is way bigger than 2. And is 18 greater than 2? Yep, 18 is greater than 2. So I'm going to use equation 3 for this one. Now, equation 3 looks a little different because it's just a number. That means there is no x to plug in. So pretty much for any x value that's bigger than 2, the y value is just going to be 12. It's like a constant equation. So you just don't, it's kind of nice because you don't even have to plug x in to know y. So for letter G, I don't even really have to show any work because I know that y is just going to equal 12. And there's my answer. Alright, so hopefully that was enough examples to get you started. If not, there is a second video, so take a look at that if you feel like you need a little extra practice with it. Otherwise, try that worksheet. If you have any questions, just raise your hand and we'll come on by and help you out. Thanks for watching and listening. See ya.